Chapter 7.3 Integer Exponents, the Zero and Negative Exponent Rules. So let's review some of the exponent rules that we've studied previously. So first of all, we have the product rule where we have two powers with the same base being multiplied. Here's where you add their exponents, so a to the power of m plus n. Then we have the quotient rule where we have two powers with the same base being divided. The result is we subtract their exponents, m minus n. And then the next rule was the power of a power rule. So a power raised to another exponent is where we have to multiply their exponents, so m times n. Then we have the distributive rule. So if we had two parts to the base, we can distribute the exponent to each part. So a to the power of m and b to the power of m. And same thing if we had a base with two parts being divided, we can distribute the exponent to both the top part and the bottom part, like so. Okay, so let's look at some other exponent rules. So here's the expression 7 to the power of 6 divided by 7 to the power of 6. If we write using the quotient rule, subtract the exponents, 6 minus 6, we get 0, so 7 to the power of 0. What's that equal to? Well, if you write the expanded form, so 6 sevens in the top being multiplied, and 6 sevens in the bottom being multiplied, well, what results is you can cancel numbers on the top and the bottom because everything's being multiplied. And whenever you divide a number by itself, it's always equal to 1, right? So you're going to get 1. So 7 to the power of 0 equals 1. It turns out that any value except 0 raised to the exponent 0 is equal to 1. So a to the power of 0, 1. Okay. So what about, here's another one, x to the power of 3 over x to the power of 3. Same thing is x to the power of 0, which is 1. Now let's move on to a new one, negative exponents. What happens when we apply the quotient rule, 7 to the power of 2 divided by 7 to the power of 5? So we take the power and we subtract the exponents, top one minus the bottom one, so 2 minus 5. We're going to get a negative exponent, 7 to the exponent negative 3. So how can I write that in a way that's a little bit more understandable or makes a lot of sense? We start by writing the expanded form. So 7 times 7, which is 7 squared on the top, divided by 7 to the power of 5. So 7 times 7 times 7 times 7 times 7. So 5 sevens on the bottom. Now if I start making cancellations, so 7 on the top cancels with the 7 on the bottom, another 7 on the top cancels with the 7 on the bottom, and I'm left with 3 sevens. I can write this as, well, whenever you divide a number by itself, so 7 divided by 7, I get a 1. So 1 has to be on the top. You have to have a number on the top. And on the bottom, 7 times 7 times 7 can be written as 7 cubed. So I can take a negative exponent and write it as its reciprocal, 1 over 7 cubed, but change the exponent at the bottom from a negative to a positive, right? So any base raised to a negative exponent is equal to the reciprocal of the base raised to the same positive exponent. So if you see a negative exponent, write the reciprocal, 1 over a, and change the exponent from negative to positive. Okay, let's try another one. If you had 2 to the power of negative 4 over 3 to the power of negative 4, I can rewrite that as the reciprocal. So you take the number 2 to the negative 4, move it to the bottom, so 2 to the power of positive 4. Here, this 3 to the power of negative 4 can be moved to the top, because 3 to the power of positive 4. Okay. What's another way of looking at this? Well, another way of looking at this would be to write 2 over 3, right? It's 2 over 3 raised to the power of negative 4, right? So what happens? Well, think about it this way. Well, if I had something like a base with exponent -4, if the rule is to take the reciprocal, well, I would just take, this would become 3 over 2, and then I can change the exponent from a negative to a positive. Same result. Even this one here could turn into the same answer, 3 over 2 to the power of +4. Okay? So any fractional base raised to the negative exponent is equal to the reciprocal of the base raised to the same positive exponent. So I can change a over b to the power of -m to be b over a to the power of +m. Okay, so that's what we call the negative exponent rule. Next, we're going to look at some examples. So evaluate each. 12 to the power of 0. So here's the application of the 0 exponent rule. So 12 to the power of 0 is 1. Anything raised to the power of 0 is 1. X to the power of 0 is also 1. Careful with this one. 7 to the power of 0 is 1. You do that together, and then you put the negative afterwards. So -1. Okay. If it was -7 in brackets to the power of 0, that would be also +1. Okay. Here we have 6 squared to the power of 0, which is 1, plus 6 to the power of 0 is 1. That's being squared, so 1 squared is 1, and 1 plus 1 is equal to 2. Okay, so what about negative exponents? So 3 to the power of -4, I can rewrite that as 1 over 3 to the power of 4. Okay, -4 to the power of -3, I can write that as 1 over -4 to the power of 3. Then it also asks us to evaluate. So you'd have to know, well, what's 3 to the power of 4? Well, 3 to the power of 4 is just 3 times 3, which is 9, times 3 is 27, times 3 again is 81. So 1 over 81. 4 cubed would be, so -4 times -4 is +16, times -4 again is -64. So 1 over -64. Here, this is just a variable, so we'll just simplify this as 1 over -x to the power of 6. Here in the next one, you have to use the power of the power rule, so multiply the exponents. So 2 cubed times -2, which is 2 to the power of -6. Okay, so all the other rules still apply, even though if you have negative numbers in there. Then you change the negative exponent to a positive exponent, so 1 over 2 to the power of 6. Okay, so you always have to change, whenever you're involved with numbers, change that negative exponent to a positive exponent. That's proper form. And the last one here, 9 over, -7 over 9, we can take the reciprocal, so 9 over -7. Then we change exponents from negative to positive. Okay. You can also distribute, so 9 squared over -7 squared. When you're dealing with negative parts, put it in brackets. Okay. And then simplify, 9 squared is 81, -7 times -7 is +49. Okay, example 3. Now that's more of a combination of rules here. So example 3, we're going to combine the old rules and the new negative exponent rules and the 0 rules. So here I have 3 and a 2. If their powers being multiplied, you have to add the exponents. So 3 plus 2. The bottom of x to the power of 5. 3 plus 2 is 5 over x to the power of 5. So term power on the top divided by the same thing on the bottom equals 1. Okay? Just like numbers, 5 divided by 5 is equal to 1. 10 divided by 10 is equal to 1. X divided by x is equal to 1. Okay, let's look at the next one. So 3 and -2. Let's add those exponents. So if the base is 3, add the exponents. So 3 plus -2 over 3 to the power of 4. So 3 plus -2 is +1. So 3 to the power of 1 over 3 to the power of 4. Quotient rule would now have to be applied here. So 3 to the power of 1 minus 4. And then we have 3 to the power of 1 minus 4 is -3. And lastly, you don't want to leave it as a negative exponent. Turn it into a positive exponent. So 1 over 3 to the power of +3. Okay. What about this next one? 2 over 3 times, x is canceled. This can cancel this. These are the same terms. Okay, 2 over 3 to the power of negative 1. Change that exponent from a negative to a positive by taking the reciprocal of the base, because remember this is now a fraction. So flip the parts here and change the exponent to a positive 1. And if the exponent is positive 1, you don't need the exponent. You can just say it's 3 over 2. Okay, and this one here, 2 to the power of negative cubed, so 2 to the power of negative 3. That can be written as 1 over 2 to the power of positive 3. And the next one here, plus, you can distribute the exponent to each part. So 1 to the power of 3 over 2 to the power of 3. And 1 to the power of 3 is just equal to 1. I have the same denominator, so I can combine the fractions, so 2 to the power of 3. Add the numerators, 1 plus 1. And I get 2 over 2 cubed. I might stop there, but you can simplify this further. Remember, there's the invisible exponent. Same base, so 2 and 2. Combine them, so the quotient rule, 1 and 3 are the exponents. So write the base as 2, subtract the exponents, 1 minus 3. And then I get 2 to the power of negative 2, which you convert to a positive exponent by taking the reciprocal, 1 over 2 squared. So negative 2 becomes a positive exponent on the bottom. And then I take 2 squared, which is 4. So that's equal to 1 over 4. Okay, so just to recap, let's go back to the rules. So the rules are, if I have a negative exponent with a single base, single part, just write the reciprocal, 1 over 7, and change the exponent from negative to positive. And if I have a fractional base, so let's say 2 over 3 to the power of negative 4, just change it by flipping the fraction, 3 over 2, still a reciprocal, change the exponent from negative to positive. And that's it. And don't forget the zero rule. So the zero exponents mean your answer is always 1. Okay, and that ends this video.